example, if you look out your living room window and you see the sun in the west and you see a reflection of the sun in the glass itself, and you take a picture of the reflecting sun that's in the glass, and you think that that's the sun. But in actual fact, you can't see it because it's on the other side of the wall, right? It would be the same type of effect. You're just taking a picture of a reflection. Like, I'm leaning really heavily towards the triboluminescence and the crystalluminescence and all of these electromechanical processes within the firmament layer being itself electrically active, like a Gaussian sphere of superfluid, right? At super cold temperatures, we know that noble gases will turn into a superfluid. And that's like cloud chamber experiments at MIT, and you can go look them up and watch the videos, and they're just awesome. What I did notice too, my main point of my research during the Eclipse event was, like this image here as an example, this really intensely focused blue orb, half crescent shaped thing that we saw, and you can see it's being refracted. The red is natural refraction that happens all the time in normal pictures, but this blue thing that was forward projected, and it came in at all these different angles, and the common globe explanation is, oh well, it came through the pinholes in the trees and whatever, and like a pinhole camera, right? And depending on where you were during the eclipse, the angles changed. You can see that if I zoom in a little bit on so I'm going to call this guy Schrodinger's cat, because he's both in our box and he's also dead and alive. And so anyway, you can see that as this image of that blue crescent now turned white as it comes through our, because the blue gets phased out as it comes through the air, right? It's just blue sky cancels blue light, you get white. But that's what's kind of going on here. But you can see that as the images were stacked, right, they're brighter in certain areas because they're being laid on top of each other. So it's multiple forward projections being scattered in all directions. And it's like a laser beam being stacked upon another laser beam. And the only way I could figure to do that was using that type of a model. I actually did a three-dimensional solid. I can find it here. Just trying to replicate it, right? And I couldn't do it.
Yeah, NASA's calling this a camera obscura effect, right?
Yeah, that's what they're saying. Yeah, but that's totally nonsense.
I agree.
Well, I'm an artist too. Like I've done, and I know Steve's wife's an artist too, and she does some great work. She's an artist too, so she'd probably tell you the same thing, that when you use a camera obscura type of effect, you take a pinhole and it'll project the entire background scene upside down onto a wall. Then you can trace it out in pencil, flip your canvas over, and then paint it, right? That's an old technique, hundreds of years old. The old artists like Michelangelo and all those guys used that. But it doesn't do singular images. It projects the entire scene. Like on the left side of this wall, it's the entire street being projected. So it's not camera obscura by any means. It's more something like this is what we're seeing going on, is like a refraction through multiple mediums of crystal lattice coming. So this would be like the sun appearing to you in the air, coming through multiple layers of refraction and crystal lattice. That's the only thing that can explain it, because down each image, you have to consider that each one of these little images is being projected by a single crystal type of object from different angles. So as the light comes down to the center of a crystal, you're getting like a laser effect. And that's exactly what's happening.
Yeah, we actually saw stuff like that happening in midair with our balloon launch that we launched, which I thought was extraordinary, as well as, cameras on the ground. And of course, most people would say, well, that's just some sort of a lens flare or something like that. But there are so many of those where that crescent tracks perfectly with the sun. You have to wonder, how is that possible? So yeah, I agree with you totally. There's something else going on there, and I believe it has everything to do with that, with a crystalline structure up there. Whether it's the sun projecting through it, or whether it's the firmament that's causing it, or whatever. But something is causing multiple diffractions, of that image itself.
Yep, absolutely. That's what I did in my solid model, and I was going to maybe even send this to Steve to see if him and Mike could do some animations on some things and try to tie it into their work with the electrical toroidal effect. In this model, I just had a square, basically a square cube that I put in the particle properties and made it anisotropic, like to simulate crystals. And then this is basically would be our UGS ellipsoid in the orange here, where my little cursor is. If you can see my little box there.
Yeah, I can see it.
that's good. Right, so that's where we are, and there's 3 planes of different levels of atmosphere. So I put in the right, 0.065 is the density of the air, and I stacked it 3 times. So we get a layered temperature gradient, and then on the bottom, on the solid model looking out, that's what you would see is the sun appearing in the sky, and this is basically the moon. I stuck a moon in here, and but from the outside looking in, where you could see where, depending on the angle of the light, because anisotropic light, what happens in crystals is it allows light to come into a crystal, and it only exits in one direction. So that gives light a propagation through a straight line, and we perceive that as time, right? Like light is time, literally, because it comes to us in one direction. If light scattered in all directions, which it should in theory in the vacuum, right? That's what happens in a vacuum. It just scatters everywhere equally. Then we would have, like, space to us just be a giant glowing glow, right? Until once it hit our atmosphere plane, everything would light up. It would just be crazy. It wouldn't be any direction to any light. It should be everywhere all at the same time, completely saturated. So in the model I'm developing, and I'm not showing the toroidal field here, but I do have a toroidal field up above and below this, and that's where the focal point would cause the sun. It's actually in this crystal lattice of the firmament, call it the firmament or superfluid space, which is full. It's not a vacuum, It's the sun appears on the dome itself. That's where we see it up here in our sky, which is the UGS ellipsoid 1984, right? And we see it here. So, like you were saying earlier, as you travel around in that, it hits that, refracts to your focal point, and you see it wherever you are. With underneath that is where you would see it rendering to you. So these are just shots of what that model will render. That's it. There it is right there. Right. It does the moon phases. It's just particles. So
I'm a little confused because you're saying the top part of that is what is representative of the WGS 84, but I thought that this would be more representative of, like, a dome firmament or whatever. And if not, then where exactly is the dielectric inertial plane? I assume that these layers that go down are like layers of atmosphere, specifically truncated off, or am I just reading this wrong?
This would be, the blue layers are just different layers I put in for plane atmosphere, right? So they're just at different gradients of density. And this is like a pressure, the dome, you could call it the dome, is the pressure wave or the pressure point of a magnetic field. So it just kind of, electricity creates pressure, right? So it has to be a closed system in order to have pressure,
right? Because
you can't just have air exposed to a vacuum, because there's nothing for it to be held together with, right? It would just be blasted off. So it's so this would be like the electromagnetic pressure wave or pressure dome, and then above that would be, who knows, like it has to have these crystal properties in order to have the light coming into it and being scattered, like we saw in the rendering, right? You would see a focal point and then rendering of different. So it should be scattered above. Yeah.
So you're saying essentially that rather than a crystalline type of structure for the firmament, it is more of a pressure generated by an EM wave, as in the top of the toroidal field. Is that what you're saying, or?
There's a Gaussian sphere or Gaussian dome boundary layer that allows us to maintain pressure under it, but above that would be the crystalline liquid, superluminous, fluid, triboluminescent liquid type of atmosphere, of whatever region that is. That would be the firmament in basically this cube. Just kind of represents it. But I would normally put it as spheres upon spheres upon spheres.
Okay.
Because we do see that when you look at the sky at night, right, you'll see that like the Milky Way has a shadow, right? One side is a mirror of the other side. Like the lit side is mirrored by the shadow side. When you look at stars reflecting in water, some will be duplicated in the sky, and you won't see them in the water.